Newton's first law of motion states that an object at rest will remain at rest, and an object in motion will continue in motion at a constant speed in a straight line unless a resultant force acts on it. Okay, so if you take a look at here, this second statement or second line that says constant speed in a straight line. Now, what it essentially means is that the object is moving with constant velocity. And if you recall from the topic of kinematics, when velocity is constant, that means acceleration must be zero, right? So if F net equals to ma and acceleration equals to zero, this is only possible if the net force acting on the object equals to zero, right? So this is unless a resultant force acts on it, if not, the velocity should be constant. Okay, so an object that is at rest, if velocity is zero, it should remain at zero. Okay, if not, then it will move with that constant velocity in a straight line. Okay, this Newton's first law is also known as the law of inertia. And inertia is the body's tendency to continue with its state of either at rest or motion. Okay, so at rest means it remains at rest. In motion, that it continues with that same velocity. The larger the mass of the object, the higher its inertia. Example 6.4.1, explain the following using Newton's first law of motion. Okay, when standing in a bus, you tend to continue to move forward when the bus decelerates to a stop. Okay, so some of you might have experienced, okay, when you are on the bus and the driver suddenly jams on the brake, okay, you may feel that your whole body tends to move forward. Okay, why is that so? We're going to watch a very, very short demo first, okay, before we take down the answer. Okay, so this video over here shows us, okay, what happens when this chair, okay, that is moving forward, okay, suddenly comes to rest. Okay, what happens to the books? So you can imagine this chair, okay, to be the bus, okay, and you are one of the books, okay, on the chair. So let's take a look now. Okay, so you can see that when this chair comes to an abrupt stop, okay, the books over here will continue, okay, in their forward direction, okay, and therefore they launch forward, okay. So in answering, we'll say that the principle itself is Newton's first law, okay. The context of the question is that the passenger was already on the bus that is moving forward, right? So the passenger will continue to move forward with constant speed in a straight line. So we are essentially actually quoting Newton's first law, okay, but applying to the context of the question, okay? Okay, when the bus itself comes to a rest. Okay, next, part B, when the roller coaster initially traveling in a straight line at constant speed turns right, and the people in it are seen to swing their body to the left of their seats. So we take a look at what was happening initially first, okay? So initially, the roller coaster is traveling in a straight line at constant speed. So the people in the roller coaster are moving together with the roller coaster. Now that means that the people will also be moving in a straight line at a constant speed. So while they are going in this straight line at constant speed, the roller coaster suddenly turns to the right. Okay. So let's take a look at the diagram below. So these are the people inside the roller coaster. Okay. So if not for the roller coaster turning, okay, then these people will tend to continue their motion in a straight line. with constant velocity. Okay, however, when the people are moving in a forward direction, the roller coaster suddenly turns to the right. Okay, so if the people are here, okay, in the same straight line motion, okay, and the roller coaster is turning to the right, okay, then relative to the roller coaster, it will seem like the people have slide to the left. Okay, so answering the question using Newton's first law, we'll say that when the roller coaster suddenly turns right, okay, the people will continue to move in a straight line at constant velocity according to Newton's first law. So quote the principle. Okay, so relative to the roller coaster, which is going to the right, they appear to be swinging to the left. Okay, because they have a tendency to remain in that constant velocity when take a look at the roller coaster. It's the roller coaster itself that has shifted to the right. So here from its original position. Okay, therefore, relative to the roller coaster, the people seem to shift towards the left of the roller coaster.